come back to that later. We went ahead and just did that triangle problem. So let's go ahead and work with this for a minute and see if this makes sense to you. Okay. Well, this is a physics problem, and it's basically, you don't have to know any physics. It's mainly an arithmetic problem. Can you handle the arithmetic? So one thing is A is equal to 12. So we're going to plug the A in there. The other thing is G is 32 feet per second. So that's going to plug in there. And then theta is 45. Okay, now don't worry about the units on this. The units are all going to work out. Just plug in your numbers. And I like to go over this problem just to kind of see if you know how to handle the arithmetic. So what we would have if you plug everything in is we'd have the square root of 2 times 12. A is 12. So we have that. And then we would have G. G is 32. Okay, and that's an actual physics constant. Okay, and then you'd have sine of 45 times cosine of 45 like this, okay? One of the reasons I like to do this is because if you get into science classes, you have to work with formulas all the time, and sometimes the arithmetic gets a little messy, so that's what I want to go through on that. Okay, let's work out what we can, and if we go through and do that, the numerator is going to be 24, of course. The denominator, you have 32. Now, we need to look at the triangle for 45. Okay, remember that the sine is opposite over hypotenuse, and the cosine's adjacent over hypotenuse. So if you look at 45 degrees on this, okay, what's the sine going to be? Opposite over hypotenuse, right? So that sine is going to be, that right there is going to be 1 over the square root of 2, okay? What's the cosine going to be if it's adjacent over hypotenuse? Same thing, exactly. Thank you. That's adjacent. That's hypotenuse. So that's going to be also 1 over root 2. Now, what you want to do is probably rationalize the denominator. You might as well do it now. So remember what we've done in the past is if you rationalize that denominator, you multiply by square root of 2 over 2. And what do you get there? Square root of 2 over 2. Okay, like that. So what we're going to do is plug those things in like this. So we're going to have the sine of 45. We're going to change that to square root of 2 over 2. And then the cosine is also square root of 2 over 2 like that. Okay? Cosine and sine of 45 are the same. The reason is they're cofunctions. And 45 and 45 are complementary. Do you guys remember anything about that? Okay? If you do the sine and cosine of complementary angles, they're always the same. And 45 and 45 are complementary. Okay, so here's what we're going to do. The rest of it's arithmetic. So what I'm going to do, I've got 24 here. Then I'm just going to multiply all this out and get 32. If you do square root of 2 times square root of 2, that's square root of 4. And then if you do 2 times 2, that's 4. Like that. Now, there's a variety of ways you can do this. This is just what I think is the easiest probably to follow. Okay, now finishing up from here, we're going to have 24. We still have the 24. Now, what I'm going to do here is 32 over 4 is 8. Right? So that's going to become 8. And then you have the square root of 4 is 2 like that. Okay? So that's how the arithmetic goes. Does that look okay to everybody? Okay? So now what we're going to have is square root of 24 over 16. Okay? Now you're just going to take this as far as you can. So we're going to go ahead and just reduce that fraction. Both 24 and 16 divide by 8. So I'm going to do it that way, okay? So if I do that, what does that reduce to? Okay, 3 over 2, right? Okay, so we got that. Now what we want to do is we want to write this in a more of a rationalized form like this. So what I'm going to do is just break this up. Anytime you have a radical, you can break it up as the numerator and denominator separately, and then rationalize denominator. So how are you going to rationalize denominator? Multiply by square root of 2 over square root of 2, right? Okay, so you're going to do that all the time in this semester. So we do that. The answer would be square root of 6 if you multiply the numerator out. The denominator is 2. That's your exact answer, okay? And the purpose of that problem mostly is just to get you comfortable with some arithmetic that's got a lot of stuff going on in it, okay? Kind of messy arithmetic. That's the bigger purpose. If you're in a physics class or something, you're more likely to get it down to that point and get a decimal answer, okay? So the idea is kind of the simplification on that, okay? All right, does everybody follow? You think okay what I did? Okay, give me a sign. Yes, no, I don't know. Okay, all right. Okay, now we're going to go on to the next page. The rest of what we're going to do is work on some triangle problems here and kind of get these going. Most of these things, the key is getting your diagram right. I don't think this is in your packet, but it's kind of worth just making a note to yourself. If you have angle of elevation, because you'll see this in these word problems a lot, what that means is you're looking up at something. So for instance, if I'm looking across the classroom at the top of the ceiling, that's an angle of elevation. I'm measuring the line that's parallel to the ground with whatever I'm looking at. That's called angle of elevation. Angle of depression would be, okay, I'm looking down at the floor. Okay, so it would be the angle between the line that's parallel to the ground and whatever it is making the floor, okay, like that. So you want to either make just kind of a basic diagram. You don't have to draw the dog in the airplane, I don't care, but the idea is know what we mean by angle of elevation and angle of depression, because you're going to need to know that to work out these problems, okay? So let's try this 15 and kind of see what we got going on. It says we have a tree that casts a shadow of 26 meters. And then it says the angle of elevation, and I don't like the way this is worded. Let's change the of to the sun. Okay, to me it's more logical if I write it that way. It'll make more sense to you. Okay, what we're going to do is we're going to find the height of the tree. So we can use trigonometry indirectly to measure things. Okay, if we can just turn it into a triangle, and all you got to know is two parts of a triangle. If you know two parts, then you can use trig to find another part. Okay, so let's do this. Okay, let's draw a tree. Okay, so there's my tree, like that. Okay, and then what we're going to have is the tree is casting a shadow. Okay, there's my shadow. Okay, and it tells me that shadow is 26 meters long. So see, we're going to try to make a triangle out of this. Okay, then it says the angle of elevation to the sun. Well, okay, the sun has to be up here. That's the reason why we have a shadow, right? Okay, wherever the sun is would tell you how the shadow is. So like if the sun is directly above the tree, you don't have a shadow, right? But if that's at an angle, the shadow will get longer and longer. So if I'm saying angle of elevation to the sun, what I'm really talking about is this. Okay, there's the sun right there. So that's your diagram right there, and that angle of elevation is going to be this angle here. It's between the ground and whatever you're looking up at. So that right there would be your 24 degrees, okay? The first part of these problems that sometimes is challenging is just to get everything set up correctly, okay? Now, do you see a right triangle? I hope you do. We assume that the tree's at a right angle. We have to, because if we don't, we wouldn't know how to do this problem yet, okay? So let's see, what are we doing? We're finding the height of the tree. So that means we need to be finding this piece right here. So let's just give it a variable. H is okay. And then we have enough information to solve this problem because of trigonometry. Okay? So one of the things that you want to do is whenever you're doing these problems, either do the sine, the cosine, or the tangent. Don't do anything else. There's no need to use those reciprocals. And really all you got to do is just figure out which of those is going to be the best one to use. So you always look at the angle that you know. You know that angle, right? If you talk that out, what do we call that? That's the side what? Opposite. What's that? Adjacent, and that's hypotenuse. So which one would be the best one to use if you have opposite and hypotenuse? Tangent, right? Okay, so you're going to say tangent of 24 equals h over 26, and then you'll have an equation that's got one unknown in it, and then you have the ability to solve that, okay? So you always look at the angle and try to match up what you have, okay? And you got to have one unknown. So here's how you'll finish the problem. You'll say tangent of 24 degrees is equal to h over 26, okay? Just solve that equation for h, you got it made. You are going to have to use your calculator on this thing too. So I need to pull my calculator up on this too because I need to use it quite a bit tonight. Okay, so if you're solving this equation, one way to do this is just multiply both sides by 26. Okay, the reason you could do that is because of that. That gets the h by itself. Now you would just get your calculator out And you have to be in degree mode. Be sure when you're doing these problems that you're real cautious about what mode you're in. Okay, so let me get this thing set up here. Okay, so let's see, I'm going to go to degree mode. It looks like I'm in radian mode, so I need to go ahead and get over there. All these triangle problems, you're going to be in degree mode. Okay, so all you should have to do then is just go 26 times the tangent of 24, and then we'll round it off to whatever I say. In this problem, I'm saying round to the nearest meter, so that would be 11.5, so you'd take that up to 12. And that would be, I'm saying a whole number like that, so we'd say 12 meters, okay? That's how that works out. So that's actually a very practical kind of thing. Surveyors typically use trigonometry all the time to measure things indirectly, okay? If you've got something that's real super tall, one way to do that is to measure the angle of elevation and then be able to measure this. It's easy to measure stuff that's on the ground. So what surveyors do is they have an instrument they call a secant, and they look through it to measure angles. Okay, has anybody ever surveyed in here? Have you? You use something kind of like that? I think they call it a secant. Is that right? Or?
I think so. I don't.
Yeah. Okay. And probably in the modern world, I imagine it's digital. I mean, in the old days it used to kind of, you had that. It was more of an analog type of thing like that. But the idea is a surveyor can measure angles of elevation and depression, and that's how we can measure things. Okay. Indirectly, other choices to climb up the tree with a tape measure, okay? Those are the two choices. Trigonometry is a little cleaner and neater and safer. Trig saves lives, okay? All right, you guys understand what I did there? Okay, all right. So really, all these problems boil down to a triangle. Sometimes they're pretty straightforward, sometimes they're not. It depends on the situation. Okay, so let's see what we have on this one. This one we have, it says, from the edge of a 1,000-foot cliff, the angles of depression to two cars in the valley are 21 and 28. So we're going to figure out how far apart the cars are. Okay, well, there's several ways to draw this. First thing I'm going to do on this is going to be my cliff. And I'm going to label that cliff is 1,000 feet high. Okay, now what you're doing is you're on top of the cliff. You're on the edge, so you are there. Okay, that's you. Okay, and down below somewhere, you've got two cars. I'm going to call this car 1, and I'm going to call that car 2. Okay, we're going to have enough information to figure out how far apart those cars are based on the angles that I've measured. Okay, so here's the idea. First of all, you got to understand what it says by angle of depression of the two cars. Okay, so here's what you got to look at. Anytime you do the angle of depression, you're always looking at what we call your line of sight. That would be parallel to the ground. Okay, so that's why I'm drawing that out the way it is. Now, if I go like this, if I draw this line like that, this right here would be an angle of depression. So that would be the angle of depression to car 1, is that angle. Okay, then if you go to car 2, well, okay, you could get a slightly different angle of depression, which would go from here to here. So what you have is you have two of those. Well, it's pretty easy to know which is which. The 21 is the smaller one, so this angle right here is 21 degrees. Okay, it's angle of depression, so look at the line of sight, and then the angle that you're looking down on like that. Okay, now the other one would be this, and that would be that entire angle would be 28 degrees. So you got to be kind of careful about that when you put it together. Okay, does that make sense? What I mean by angle of depression, tell me. Okay, all right. That's one of the things that students a lot of times don't look at. They look at the wrong angle. So those are the two angles right there and what they mean. Okay, let's see if we have anything else. We actually don't have anything else. So now what we have is you can see kind of a big right triangle. And what you're going to do is you're going to find this distance right here that I've highlighted. So that's going to be our unknown. You can pick any variable you want to. I'm just going to use D for distance like that. Okay. Now this is a problem that you have to probably take several steps to solve. So what you have to do is, all we know how to do is use right triangles. Now if you look at this diagram, hopefully you see two right triangles. There is this right triangle right there, and then there's the big right triangle, right? So one approach to this problem, there's a couple approaches actually. One thing you could do is you could figure out this whole side here. From there to there, you could figure that whole thing out, right? You could also figure this out. So if you could figure this out and that out, then what would you do to figure out the leftover area? Subtract, exactly. So that's the approach I'm going to take. The first thing that students a lot of times don't know, because this comes from geometry, and we have what we call, and this is real important in these problems, we have what we call alternate interior angles. Okay, let me just explain what that is. The idea is anytime you have two parallel lines and you cut them with a line like this angle here and that angle there are the same. You can tell by looking that they're the same. So we call that an alternate interior angle. So if you look at this, notice that if this angle's 21, and so is that. You said, okay, you got this line and that line are parallel, so that if that's 21, that is. If this whole thing is 28, then you should be able to figure out what that angle or what that angle is. So what you have to do is you have to figure out angles on this. So the first thing I'm going to do is, because of what I know about alternate interior angles, what you'd end up having is if this thing right here is 21, then so is this. Okay, does that make sense? Okay, we call that an alternate interior angle. That's one way to figure that out. Okay, so we have that, and that will help us with the big triangle. And then we need to figure out this right here. Okay, and there's several ways you can do this. Just think about this. I'm just going to do whatever I kind of think here. If this angle from here to here is 21, and from there to there is 28, what is that little angle right there? That'd be 7, right? Okay. 21 plus 7 is 28. So that's 7 degrees right there. And then that might help us to piece together the rest of the problem. So this angle is 7 degrees like that. Okay. Now there's several approaches here. One thing you could do is notice that these angles right here, they all add up to 180, don't they? So you could figure out this angle here, and then that would allow you to figure that angle out. This is just what I'm seeing, but there's other ways to do this. So what I'm going to do is I'm going to do 180 minus the 21, and then minus the 7, and then that'll end up giving me this angle right here, which we now know is 152 degrees. So I've got the 3 angles in that triangle like that then, okay? Now that's going to leave me with figuring this angle right here. So you can figure that out. What is this angle, or let me ask you, how would you find that angle based on what I've done so far? 180 minus that, right? So a straight angle is 180, so you just need to take 180 minus that to figure out what that is. Then we've got enough angles to figure this out. Now there's more than one way to do this problem, but the key thing is you got to figure out these angles. Okay, so what I'm going to do is just go 180 and then minus 152, and I'll record that. That's a 28 degree angle. Now I knew that automatically. I don't know if you did. You see why it's 28? Okay. We have what we call an alternate interior angle. So see, this whole angle is 28, so is that. Okay, so you could have done that too. Okay, there's a lot of ways to do that. If you don't see the alternate interior angles, you should still be able to finish it up. Okay, so here's what I'm going to do now is we're going to look at these 2 triangles, and it's probably not a bad idea to just draw these 2 triangles out. The first right triangle I'm going to look at is we have 1,000 feet. We have this distance right here, and I'm going to call that some other variable, like I'll call it x. Okay, I'm going to call that x. Okay, and then that angle is 28 degrees right there, so we could easily find x using trigonometry. Okay, that's the small triangle. Okay, now what I'm going to do is look at the bigger triangle, and that bigger triangle would go like this. Okay, we would still have 1,000 feet, a right angle, and then now this angle would be 21 degrees, and then we could go ahead and figure that out. We could give that another variable name like that. Okay, so let me kind of show you what my thought process is. This is the small triangle, 1,000, this, and 28. Now all it takes is 2 parts of the triangle to figure out the rest, other than the 90 degree angle. So we have an angle on the side, so we should be able to find x very easily. Now we're going to take the big triangle with the angle 21 The side opposite's still 1,000, and we're going to find that whole side. Then what we're going to do is take this whole side minus that side to get what's left over. That's the strategy I'm going to use. Does that make sense? Okay. So we're going to go ahead and do the trig then to finish this up then. Okay, so for each triangle, then of course we have to use our calculator on this. Okay, so if you look at this angle and you look at what I gave you, this is a side opposite. That's an adjacent, so again, that's a tangent. The tangent's opposite over adjacent, so you would have to have the tangent of 28 degrees is equal to 1,000 over x like that. Okay, and if you can solve that equation for x, you got what that distance is. Okay, now what I'm going to do on this one is there's several ways you can do this. You can cross multiply, or you can even do this. You can turn both sides upside down and then get rid of the 1,000. I think most of the time students seem to have this background for cross multiplying. So I'm just going to have x times tangent of 28 equals 1,000. Okay, then I need to just divide by tangent of 28 degrees, take my calculator, and then that'll give me what that value is. Okay, so we just get our calculator out, and that'll give us that piece of the small triangle, and we'll just round that off to like 1 decimal or something. Okay, so you want to make sure that you're in degree mode. You go 1,000 divided by tangent of 28. Okay, like that. And then that will give me 1,880.7 units. I forget what the units are. I guess the units are feet, like that. Okay, so that's the first part of the problem like that. All right, you guys understand what I just did, okay? Okay. Now let's work with the big triangle. The big triangle, you have this angle, this side opposite, and that side adjacent. It's still the tangent, isn't it? You're going to do exactly the same thing again. So with this second triangle, you're going to have tangent of 21 degrees is equal to side opposite, 1,000, over side adjacent y, and then we just solve that, and then we'll get our two numbers, and we can get the answer, okay? So again, cross multiply. And, you know, when you get down to this point, if you're ready to go to your calculator, a lot of times students can kind of rearrange that in your head and just get your calculator out. I'm okay. As long as you've got that set up okay, the rest of it you can go to the calculator. So if you cross multiply, you would have y times tangent of 21 is equal to 1,000. Okay, then you would divide both sides by tangent of 21 to cross that out. Okay, then we just go to the calculator to get that then. Okay, and let's see, we're going to do that on the calculator, and let's see what I end up getting here. So 1,000 and divide by tangent of 21. Okay, hopefully I get a bigger number than I did the last time, and I do. So that's going to be about 2,605.1 feet like that if you round that off. Okay, so the two key things I have is I have this and I have that. Okay, so what do I do with those two numbers? You subtract them, right? Okay, so remember what I just did in this problem essentially is I got the big distance of the big triangle, I got the small distance, the leftover distance would be that minus that. So that's all you should have to do to find the distance between the two cars, okay? Okay, so let's see. The final answer, D, would just be 2605.1 minus 1880.7, and then that would give the distance like that. This problem has multiple steps to it, but there's enough information going on there to be able to figure that out with trig. Okay, so you could indirectly find distances in this way also. Okay, so even when you get into astronomy and things, you can figure out a lot of things this way with trigonometry. Okay, so that final answer would be 724.4 feet. That's the final answer. Okay, do you guys understand what I did okay? Okay, there's probably another way to do this. That's just what I happen to see is two right triangles. Okay, that's the idea. Okay, and I'm sure there's other ways that you can find different angles in different ways, but that would be one good way to do that problem. Okay, okay, any questions about that? Okay, actually one thing that's worth mentioning, we're going to look at this a little bit later in the semester, is the way that we figured out how far the star Proxima Centauri was trigonometry. And a mathematician named Bessel figured it out with the sine function. And at that point in time, nobody had any clue how far away stars were. And he ended up getting this number in the trillions for this star. And that kind of blew everybody's mind back in those days. And that's several hundred years ago. People had no clue how vast the universe was. Okay, that's the idea. Okay, if you're into the flat Earth theory, which it seems to be gaining popularity, if I remember right when I was reading that, they think that the sun is 3,000 feet above us. That's what they've determined. And they also determined that the moon and sun are exactly the same size. Okay, they're like 30 miles long. Okay, now why people believe that, I have no idea. But I guess you want to believe it is the idea. Okay, so let's look at one more problem. This is probably the one that takes a little bit more work. But all these triangle problems, you end up drawing a triangle, trying to use one of the trig functions to figure out some distance or some angle. Okay, so let's see what we've got going on this one. Now, I had a tree. I think I just added this in here so it's more visually pleasing to my students. Okay, you can draw a tree and a person. Okay, so here's what it says. Okay, John is 6 feet above the horizontal. So here's John, and I take that as, for all practical purposes, he's 6 feet tall. Okay, just got to make a few assumptions. Okay, now let's see. Here's what it says. It says he first measures the angle of elevation to the top of the tree at 35 degrees. Okay, so he's looking at the angle of elevation to the top of the tree as 35 degrees. Okay, now you got to understand what that means. First of all, here's the ground. Okay, what the angle of elevation is going to mean is it's going to be his line of sight, which is this. Okay, and that's parallel to the ground. And what's the angle of elevation? What would that be? He's looking up at something, so it would actually be, if you connected the top of the tree to him, that would be your angle of elevation right there. Okay, so that's what you got to know. Angle of elevation, you're always using line of sight and then to the top. So I'm just going to kind of draw that in like that, and then label that angle as 35 degrees like that. So that's what we got. And you see a triangle. There's a right triangle in there. Okay. Now let's see. The next thing it says is he walks 30 feet closer to the tree. Okay. So what I'm going to do on this is just kind of take this distance like this and just label that as 30 feet. So he's moving closer to the tree. Now what he's going to do is he's going to remeasure that angle of elevation. So he's really here. Okay, and again, I'm going to put that distance right there as 35. Now what he's doing is the angle of elevation has increased by 12. Okay, so what would that mean? Okay, he's going closer to the tree. That angle of elevation has increased by 12. So if that's 35, what's that? It's gone up by 12, so 35 plus 12 is what? 47? Okay, so we got 47. Okay. Now, one thing I want to make sure makes sense to you, because a lot of times your diagrams, if you don't think about them, won't make sense. Does it make sense to you guys that closer you get to the tree, the bigger that angle becomes? Absolutely, okay? I mean, if you're looking at something that's real close to you, then that's a real big angle. If something's really far distance, that angle of elevation is very small, so that's getting bigger, okay? So we've got those two angles. So now what we're going to end up having is we're going to try to estimate the height of the tree. So I'm going to take you through one way to do this. Now what I'm going to do is make a right triangle here, and I'm not going to find the height of the tree, but I can find the height of that triangle. Okay? So think about this a little bit. If I can figure out that height there, then what would I do to get my answer? I would just add 6 to it, right? So if I can find that, add 6 to it, that would be the height of the whole tree. So that's going to be kind of what I'm going to look at, is kind of go this way. And again, I've got a small right triangle and a big right triangle. So we need to go through and figure that out. Okay, now this one is going to be kind of difficult, because if you look at this triangle here, I only know one part. Okay, that's 47. See, I don't know that. I don't know that. I don't know that. You can figure that angle out, but that wouldn't do you any good. If you know two angles, you aren't going to get anywhere with that. Yes?
What's the 35 and 3?
Oh, this was 30. That should be 30. Yeah, okay, I put 30 there, but I put the wrong number there. My apologies. Okay? Because it says that he walked 30 feet closer to it. So that right there is 30 feet. Okay, now let me show you what we got going on. And this problem gets a little bit challenging. So we've got two triangles. What you want to do is you want to write down these two triangles. First of all, we got the big triangle. Let's just draw a picture of it because it'll help us put this together, I think. So the big triangle, you're going to have a height h and 35 degrees, but you don't know anything else. I mean, you know that this little piece from there to there is 30. You don't know enough information to figure anything out on that triangle. Because at a minimum, you always got to know an angle and a side. And you know no sides. So you aren't going to get anywhere, okay? Now, that's the big triangle. Now, if you look at the small triangle, okay, that's the one that's the 47-degree angle. You're going to have 47 degrees. Then you're going to have h, and that's it. Again, you don't have enough to figure anything out. So what you have to do here is, at a minimum, you always have to know one angle and one side. Okay, you can easily figure out that angle right there, but it wouldn't do you any good. So what you have to do is you have to get a system of equations. This is what makes this problem a little more challenging to do. So what I'm going to do is I'm going to give this distance from there to there, I'm going to give that a variable. Okay, so it's going to kind of go like this when we put this together. So I'm going to think of this piece from there to there. That I'm going to give a variable x. Okay, so what you're going to have here in the big triangle is you're going to have h and x. You're going to have two unknowns. Okay, like that. And in the small triangle, you're going to have x. Okay, now we have two unknowns, and if you got two unknowns, and if you can get two equations with the same two unknowns, you can solve the problem. Okay, so that's the idea, is you could not do this problem at this stage any other way than to create another variable. So you're going to be looking at the triangle with x and h as variables, and then what's this big side right here going to be? From all the way from there to there, what is it? 30 plus x, right. Okay, so you're going to have that. Okay, so now we're going to put this together. So watch carefully. This gets a little messy. It's not too bad, but you do have a lot of algebra to work in this problem. So we're going to do the tangent again. So on this big triangle, we're going to do the tangent of 35. And remember, the tangent is opposite over adjacent. Okay, so what you're going to have is you're going to have h over 30 plus x. That whole side's 30 plus x, right? The piece is 30, x is the rest, therefore the whole thing's 30 plus x. Does that make sense? Okay, now we're going to do the same thing with the small triangle. So now we're going to have the tangent of 47 degrees is equal to opposite over adjacent, so it's going to be h over x, like that, and that's going to be the two equations that you have to put together to solve this problem. Now, ultimately, what we're doing on this problem is we're looking for h. Our goal is to find h, okay? So is everybody okay so far? Okay, you can't do this problem without a system of equations. Now, later in the semester, we'll learn a different way to do it, but we can't do it now. We're not ready yet, okay? We have to deal with it this way. So what you have to do is you got to do these things. You got to pick an equation, and it doesn't matter which one you pick, and then you solve for either variable, okay? And it doesn't make any difference, okay? I'm just going to solve for, I'm going to take this equation right here, I'm going to work with this one, and I'm going to solve it for x. It doesn't matter. It's your call. Go ahead. Say what again? I'm sorry. Oh, I got that backwards, don't I? I haven't put that on there. So that would be h over x. Jeez, that's terrible. I even said opposite over adjacent and even highlighted. Everybody got that? Opposite's this. Adjacent's that. So that's h over x. Okay? Don't make that mistake. Gosh, I'm embarrassed at myself. Thank you for pointing that out. Okay, so here's what I'm going to do. And it's my decision on what I do. To me, it's just as easy to solve this equation for h. Or you could go up and solve this one for h. It doesn't make any difference. So what I'm going to do is I'm going to kind of move this over here, and I'm going to write down the equation tangent 47 equals h over x. And I'm going to solve this equation for h. So it just means I'm going to multiply both sides by x to get rid of the fraction. So I will have h is equal to x tangent of 47 like that, okay? So I've got that. Now what I'm going to do now is I'm going to take the second equation, And that second equation is tangent of 35 degrees equals h over 30 plus x. Now keep in mind, there's several ways you can solve this. I'm just doing one way, okay? And I'm going to do exactly the same thing. I'm going to multiply both sides by 30 plus x in order to get rid of that fraction and get the h by itself. That's why I'm doing what I'm doing. So if I do that, I would have parentheses 30 plus x times the tangent of 35 is equal to h. Okay, now this is just my decision on how to do this. The reason I'm doing it this way is now you can set these two equations equal to each other. If they're both equal to h, then this thing must be equal to that thing. Then you'll have an equation with one unknown that would allow you to find x. Now, to me, the best way to do this at this level is just go ahead and let's get our calculator, and let's just do the tangent of 47 and the tangent of 35. Okay, because I think you'll follow what I do easier if I do it this way. And let's just use like 4 decimals. So if I do tangent of 47, that's going to give me this. So this equation, let's write this tangent as 1.0724 x equals h. Okay, so that's going to be equation number 1, solve for h. And let's just use decimals. Okay, let's do the same thing here. Let's do the tangent of 35. So do tangent of 35 on the calculator, round it to like 4 decimals. So I'm going to end up having this. I'll have 30 plus x times 0.7002 is equal to h. And then I'm going to do a distributive property and just work that out like that. Okay, so what I'm going to do next is I'm just going to do a distributive property like this. Okay, so I'm going to do 30. I'm going to take that number, 30 times 0.7002. Okay, and that's going to give me 21.006. Then I got to multiply it by x to get 0.7002x equals h. Okay, now those are the two equations that we can work on. And now what I can do is I can set those equal to each other and find x easy enough. Okay, you guys get the gist of what I'm doing? Okay, again, this is one way to do it. You could have solved those equations instead of for h for x. It may be easier that way. I don't know. I mean, it's probably about the same amount of work either way you do this. So what I'm going to do now is one thing that you usually learn in like an algebra class is you can plug one thing into the other thing. So you could take that and plug it in for h. And then you would have a simple enough equation to solve. So I'm going to write down this equation, 21.006 plus 0.7002x equals h. All I'm really doing is just setting these things equal to each other, and then that's an equation I can solve for x because it's got one unknown. Okay, all right? So when I do this, I'm going to subtract this from both sides. Okay, you can do this on your calculator too if you want to. So what I'm going to do, so that would give 21.006 equals, now I'm going to take my calculator, and I'm going to do 1.0724, and then minus 0.7002. Okay, and that'll give me the like terms put together. So that's 0.3722x. Then I can divide by that number in front. Okay, like this, and then I'll get what x is. So I'll have the value of x, and then that will be real easy to get the answer to the problem now. Okay, so if I do 21.006 divided by 0.3722, okay, finally after all this work, I'm going to get x is equal to about, let's just say 56.4 feet. Okay, that's what x is. Okay, now there's a lot of work on that, but it's mostly algebra. So once you get these two equations built, what I decided to do was solve both of them for h, and that allowed me to just plug that in there. Does that make sense? Okay. Now I need to find h, so the easiest way is to go to this equation right here. Okay, if we know x, if you plug it in for x now, you'll have it. And that's what I'm going to choose to do because it's the easiest way to finish it up. Whoops, I want that. Okay, so I'll just kind of put it in here. Here's how you get the final answer. So you'd have tangent 47 degrees equals h over x. And again, x is 56.4. Solve that, and you got the answer. So how do you solve this equation? Well, you want to get rid of 56.4, so what do? Multiply both sides by 56.4. Okay, then you go to your calculator, so h should be whatever 56.4 tangent of 47 degrees is. Okay, then we'll just round that off and get an answer. Let's see what we get. I think every time I solve this problem, I always end up doing it a different way. There's several ways to look at it, but you do have to have a system of equations. So that would be h, and we're still not done. You got to be careful. You would have h equals 60.5 feet. That's not the answer to the problem, but we're almost ready to get the answer. Okay, so here's what I found. Okay, that 60.5 is not the height of the tree. It's from there to there. Okay, so what do you do to find the total height of the tree? You add the guy's height to it, right? Okay, so you got to do that. Don't forget that. You do all that work, and it's easy to forget about that. So for your final answer, here's what you would do. Okay, you just got to take the, let's see, what did we get? 60.5 plus the guy's height. So you get 66.5 feet is how tall that tree is, okay? All right, your other choice is just to climb up the tree of the tape measure, okay? But the mathematical way is a little cleaner, isn't it? Now, that's a lot of work on that. I like to show this way at the beginning of the semester because at the end of the semester, we're going to learn something called law of sines. I bet a lot of you have learned that before. Have some of you learned that before? So you can actually do this problem a little easier with something called law of sines, but you don't learn that until the end of the semester. Right now, we're focusing on triangles. That's it. Okay, that's the idea. Okay, now you got to have some kind of strategy to keep track of what you're doing, but that one is 2 equations and 2 unknowns. Now, for testing purposes,